Look at this. We can blow air just using electricity at high voltage. It comes in the side of a tube, comes out that side of a tube. No parts in there, no fans, just wires. Pretty cool, isn't it? Let's see how it works. I'm planning to go to much higher powers in my study of AC or DC ion drives, but first I thought we could, at low power, we could study some of the wire models to see which are most effective. Now, traditionally, many people have used what's called ion lifters, which work purely by an electrical force. A plus electrode there and a minus electrode there. The ions go from top to bottom, a simple electrical force. They slide around the bottom and it pushes it upward. This is called ion lifters. However, a more powerful force uses magnetism. You have current go off a plus electrode to a minus electrode across a gap, like for a rail gun. And this gives you much more power because you can accelerate not only here, but all these steps are acceleration. They all add together like a snowball. And NASA uses things like that in some of their ion drives. And here's an example. And the example we're going to look at today is the circular railgun, where we have 3 positive electrodes on the outside and 1 negative in the middle, or vice versa. And I made a little model of it. We have 3 red wires coming in one side with a black wire in the middle through a pipe, like that. And the wires run all the way the length of the device, about 6 inches. They are powered by 4 ignition coils, each 15 volts to 40,000 volts. The total power here is about 40 watts. And we power it with a little DC power supply. So when we turn it on, we want to see how much air is coming out the backside to see how powerful it is. The currents will be going across back and forth the whole way, being pushed out like for a circular rail gun, just as shown in this crop picture. You can see through it. Let's now turn it on and see how it works. And when we turn on the circular rail gun at 15 volts, 1.3 amps, you can hear the hissing of the ions being formed in the air, and also you can feel a big wind coming out on my hand that way, and there's no air on that way. In order to visualize that wind a bit more, we'll add a match and see what happens. Let's look at that again. You can see the air flowing out of it very strongly back here, you see? Even away at a distance, the air is flowing quite strongly away from the device. As we get closer, it flows very strongly. As we get closer, the match will go out because there's no oxygen there left to burn. Now for the second part of this video, I'm going to study the physics of ion flow in what's called the dragonfly drone UFO. This is a certain kind of UFO that's been photographed around the world in many places. And you can see it's sort of like a ring with lots of wires in a circle sticking out on the top. There's a photo. Here's another photo. There's a ring with lots of wires sticking out on top. And here's a close-up of the wires. You see they're sticking out like that, and there's a ring below it. So this looks sort of like what we were doing before. So I've made this model here, a ring out of plastic with 6 wires sticking out almost in a hexagon shape. And we can have the wiring of the wires either plus minus, plus minus, plus minus all around, or all plus. So we have 2 different wirings we'll test. This particular one has 3 red plus and 3 black minus. So we're going to turn on the power and see how each of these models behave, and then we'll see what we can say about the physics. This is the plus minus, plus minus, plus minus model, and you can just see a very strong flow of air going from left to right, caused by those wires on the left and voltage going through them. As we get really close, the match sort of goes out because there's no oxygen left to burn, the only ions there. Let's look at the plus minus, plus minus, plus minus model once again. So the air is just streaming off of it. Way back here, huge airflow. As we get really close, the match goes down a bit because there's no oxygen left to burn. all the air in there. Oxygen is ionized into N plus and O plus ions and electrons. This next model is plus 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 plus. Again, we can see the air flowing quite strongly from left to right, almost like before. And then it goes out as we get close to the wires where there's no oxygen left to burn, just ions. Look at that again. We've got plus 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 plus. We get a big wind once again from left to right, and then the match goes out as we get very close. Now we have studied ion flow within a simple model for this dragonfly drone UFO, which has a bunch of wires in a circle around the top. Here's another picture of it, and you see all these wires around the top with a base here, which I won't get into that. We've tried two arrangements of polarity. One is alternating plus minus and the other is all plus. And here's the all plus version with 6 red wires, and there was no black one attached. Just a simple piece of plastic. 6 wires arranged as a hexagon with 40 kilovolt DC coming into it for ignition coils. And paradoxically, what we found is both arrangements send air from left to right quite strongly through the whole of the UFO to the right. The plus-minus arrangement was better, but the plus-plus does it also. So it's not clear exactly the physics of that. I suspect it's making the ends of the molecule are making N plus O plus cations from the air, whether it's either arrangement, plus minus plus plus, and then they're going down to ground like lightning to create a flow that way and then down to ground. So that's somewhat paradoxical, because in these dragonfly UFOs the wires stick up, so the force would be that way, pushing the UFO down to the ground. So that doesn't happen. It goes exactly the opposite. So the paradox of this experiment is we're getting ion flow exactly the opposite observed for the UFO. We have to change something, either electricity or special kind of gas, maybe an anion gas rather than a cation gas. And if we do that, we can maybe make a UFO like these guys are doing. So we have a lot of alien science to learn here. Let's just keep on going and keep studying, and then we'll fly to the stars. Thank you very much.